Good morning, everybody. I'll just give it a couple more seconds here for everybody to join. All right. I think due to time, we should get going. We have the majority of everybody, I think, joined already. So, all right. So welcome, everyone, to Elos MidTech, and thank you for taking the time to join us today. Excuse me. Again, for those who don't know me, my name is Moe Elbanna. I am the Regional Sales and Development Manager for the North American region. I am also your technical advisor. I would like to remind everyone today to please ensure that you send me your CDT number if you have not submitted it in the registration form. If you are looking for those credits, I need that number to go ahead and submit it for the NBC. I also would like to remind everyone, if you have a question, please write it down in the question box. I will not be able to answer any questions during the webinar because of time restrictions. And today I would like to change things a little bit and start with a little bit of history. From time to time, because we always have newcomers, I would like to just kind of inform everybody of who we are, where we came from, and tie the events with the products. So as you guys can see, we are certainly not a young company by any means. Elos was founded deep in the heart of Sweden back in 1923. And from 23 till the mid-50s, we were manufacturing and repairing wood cutting tools to build wooden houses. Now, in the mid-50s, we actually started to get into the medtech devices. And it wasn't until 75, through a collaboration with Professor Brannemark on a project to develop osseointegration and manufacture the first dental implant for Brannemark, which was our first footprint. However, our true journey in the dental world was not till 2010 when 3Shape approached us to develop the very first desktop scan body. And that's where things pretty much took off for us. And we've been evolving ever since, adding new products, evolving our existing products, and we constantly have new stuff in the pipeline. So please stay tuned for 2026. We have great products coming in 2026. One of which is the hybrid base G. And we're going to have a special webinar when the right time comes just on that particular line. But for now, we're going to talk about our printed model analog.
The Elos Accurate Printed Model Analog, or PMA, is unlike traditional analogs that depend on a snug fit between the model and the analog itself. The Elos PMA features a patented installation method that cuts into the model, providing superior stability and accuracy. It has become a key component of major workflows utilized by many implant solutions. Before we dive deeper into the PMA, I'd like to remind everyone that our model analog that you see on the left here, which was previously used for stone models or plaster models, we stopped production on it, and it has completely phased out as the end of last year. So as of the end of 2024, it is no longer in production. Now, our PMA is obviously part of our digital solution and smart workflow, but to shed the light a little bit on the philosophy behind its development, It was not to manufacture something of more of the same of what's out there, but rather to manufacture something that would solve a problem that most of those who 3D print have recognized or struggled with at some point. We wanted something that would be technology disruptive and unique. So the issue we were trying to solve is the inaccuracy and or inconsistency is a common problem in dental 3D printing, which also includes but not limited to printed models. Now, there are some multiple pain points in the dental 3D printing, and those can be different technologies, light source, such as the DLP, SLA, and so forth. Material chemistry, shrinkage, viscosity, etc. Different post-processing and light exposures and the light curing source. Free-form geometries, different wall thicknesses and whatnot. And now all of those can have a negative effect on the implant prosthetics. That negative effect can be in the form of height offsets, over or under occlusion, rotations, and missing or excessive approximate contact points. Now, before I start on this slide, I really would like for everyone to pay close attention and focus a little bit more, because we are going to take a much deeper dive into all this here in the next 4 or 5 slides. So precision cavity printing can be very challenging. Retentive attachments are easier to produce in 3D printing and less sensitive to tolerances. Now, we have 5 types of different fits under 2 categories. The first category is we have what we call dimensional fit. And the definition of dimensional fit is the tolerance or clearance between 2 mating parts. Now, those are all defined by CAD offsets, printer accuracy, and material shrinkage. The types of dimensional fits are, we have loose fit, transitional fit, and press fit. All those 3 are part or types of the dimensional fit. Now, the second category is what we call a functional fit and or retentive fit. These describe how the parts behave functionally once assembled. Now, the retention achieved by surface friction between 2 precisely fitting components depends on the surface quality, parallelism, and the contact area, not just the geometric tolerance. And the types of functional fits are, and there are 2 of them, it's called frictional fit, and then the other one is retentive fit. So typically, transitional fit is difficult to achieve in dental 3D printing. So ideally, a combination of press, frictional, and retentive fits are the parameters needed or should be used to achieve higher precision for analogs in printed models. Now, the design of the analog is a key factor in ensuring that it is correctly positioned in the model. In addition, manufacturing tolerances in the fitting areas must be low, as every micron costs money. This is the major difference to conventional analogs, whose external geometry does not have to be tightly tolerated. It only has to hold in the plaster. However, the associated spacer design in the CAD library is also a decisive factor. The geometry that ensures the assembly hole in the model is in the correct position relative to the scan body. I have a couple examples here to illustrate some of what we have discussed. The analog in this particular example has a thin circular contact line in the upper part of the spacer, and that's part of the transitional fit. In the lower area, the spacer is visible, meaning the analog penetrates the spacer geometry in a large defined area to achieve a strong press fit. And if we look at the red areas here, that's the areas in question. Now, some of the disadvantages on this particular style are the under-contoured areas of the spacer geometry combined with the press fit maximum result certainly pose the risk of eccentric positioning. Also, no additional lock screw to secure the analog. This creates stress in the material and micro movements, especially when screwing it or unscrewing it in place. Finally, a tool to secure insertion into the axial implant positioning is not available. The second example, the analog of this manufacturer is identical to the conventional analog for plaster models. So it's more like a negative of the analog external geometry. The disadvantages are, since this analog was originally a conventional analog for plaster models, therefore it presumably does not have tight production tolerances. There are no defined contact surfaces or specific offset levels. It's left to pure chance to how far this analog will dip into the spacer and reach the correct position while or after it's inserted. And also a tool for secure insertion into the axial implant position is also not available on this one. This is probably the worst solution of all examples. Now, on this final example, this analog has a combination of precisely tolerated surfaces with various offsets, a combination of special press fit areas, frictional areas, and intentionally out of contact surfaces. Additionally, combined with several penetrating cutting wedges that cut into the model material in a controlled manner. The advantages on this particular style: the smart combination of different fit types and offset areas in the spacer allows for controlled and correctly guided integration of the analog and is therefore less sensitive to the different fit parameters of different printers and resins. Then, 3 strong locking areas prevents the analog from rotating by micro movements. Clear and visible height stops. A mounting tool guarantees correct insertion along the guided axis to a controlled end position of the analog. A controlled end position of the analog. The analog's low height reduces the model base size, thus reducing construction time and material consumption. So it is faster and easier to print and does not use as much resin. And additional locking screw provides additional security against movements. And if you have not guessed it, this is the Elos Accurate PMA. And these areas here in green are what we have described. These are the cutting wedges, the locking areas, and this is the internal geometry. Now, the Elos Accurate PMA patented installation method include the cutting wedges, obviously, that you saw here, and there are some here. In the event that excess resin is present, and that's typically where you see the areas marked in blue, the wedges will slice through these areas during their movement along their path of insertion. The second thing is the 3 locking areas, which are right here, with cutting wedges as well to prevent unwanted rotation. And finally, the threaded hole on the bottom allows the utilization of the pliers and fixation screw for the final precise fit. Now, the main takeaways out of all this are: precision fit, innovative design, proven reliability. Precision fit is the Elos PMA designed to overcome the performance differences and variation in accuracies among 3D printers. When we say innovative design, that means we're talking about the patented cutting installation method improves stability and accuracy over traditional tight fit analogs. And the proven reliability is the result of the above 2 points. The Elos PMA became widely integrated into major implant solutions due to its reliability and consistency. Now, allow me to run a short video to summarize most of what I explained. Now, let's shed the light briefly on the tools that are needed to accompany the PMAs. Now, obviously, we have the pliers, the pen, and the screws. These are 3 separate orders, 3 separate purchases, 3 separate item numbers. The plier come 1 plier per item. The pen, each item number has 2 pens, so when you purchase 1 item, you get 2 pens, and the screws come 5 in a pack. Please also remember, as you saw in the video, the back end of the plier has a magnet in it, and it actually is utilized as the screwdriver for the screw. A lot of people miss that part. And you guys can see here in the picture clearly that the PMAs are all color-coded depending on the implant manufacturer and or platform. Now, I highly encourage everyone to please purchase these things if you are utilizing our PMAs, because they are absolutely essential to achieve the best, most accurate results. Now, also for those who like to have a written document that they can look at or refer to from time to time, the step-by-step instructions are available on our website in a PDF format that you can download, and or you can scan the barcode here and it'll take you straight to the link. Also, we did a little bit of legwork for everybody. We have contacted the majority of the known printers, and working with them, we have established a particular set of parameters that you can utilize if you have any of these printers to achieve the best results in printing your models. And those PDFs are also available online on the website that you can download depending on whichever printer you have, and or you can scan this barcode and then it will take you straight to the link. Now, libraries, we obviously are compatible with Exocad and 3Shape only. We have two sets of libraries for both softwares. One is marked for with FDA, and that is for the US users, and the rest of the world is labeled with RTW, that's for the rest of the world. You will find both options on either Exocad 3 or for Exocad or for 3Shape, both on our website. And for Exocad, you could also download them from Exocad directly. Now, when it comes to regulatory and compliance, Elos Medtech is strongly committed to maintaining compliance in all markets we operate in, adhering to all applicable rules and regulations. And when it comes to lifetime guarantee, in the event of failure of the Elos accurate components, our lifetime guarantee will reimburse or replace those components. And in case of the actual implant failure, we will match the implant manufacturer guarantee 1-for-1. So literally, there are no reasons why anybody should be skeptical and or afraid they may lose their warranty if they utilize the Elos components. Now, finally, before we wrap it up, I would like to give you a quick summary and a few takeaways to just remember before we finish for the day. The Elos Accurate PMA solves the printed model inconsistency issue. Unique patented insertion method to ensure consistent accuracy. Precise height installation. Secure press fit installation. Only one possible insertion position for the PMA, and that is the correct one. Color coded according to implant manufacturers. The Elos Accurate PMA has gained wide recognition and became a key component for major workflows utilized by many implant solutions. We have available libraries for 3Shape and Exocad. Real connection geometry exported, and that's due to the library. And finally, the Elos Accurate PMA is part of the lifetime guarantee. We will get to the Q&A at this point, and thank you very much for attending and your attention. And please, if you need to tap on the Academy, you can scan the barcode and it will take you straight to the Academy page. Thanks again, and we'll start to answer some questions at this time.
All right, so let's see what questions we have. Yes, somebody's asking if they will have a recording or a copy of this recording. Everybody who signed up, whether you attended or not, you will get a link to be able to watch the video at another time on your own pace. And then also, let's see here, we have another question. It says, is the insertion screw mandatory if the analog is nice and tight? So the screws, the insulation screws are not necessarily mandatory if the analog is nice and tight and there is no movement of any kind. It becomes an optional to actually insert the screw at the very end or not. It's always a nice secure feature, but if you feel like your analog is very solid in the model, then it is not necessary to actually utilize the screw. And then we have another question. Where do I get to see the webinars on Elos Accurate videos? They are all available on our Academy. So if you guys go to the website, look for the Academy tab, and all the webinars we've done in the past, all the webinars we're going to do in the future are all going to be there. And I think we have one more. I see the Neodent GM has the same PMA for all three sizes. Is that accurate? And yes, so for the GM, all three sizes have the same internal connection. So it's just going to be one analog, one scan body, for example, one pre-milled blank for all. They differ on the outside geometry, but not on the internal connection part. So, and I think that's it for today. In the future, if anybody thinks of any other question regarding PMA or any other Elos product, please don't hesitate to send me an email, and I'll be more than happy to answer anybody's question, even at a later time. And we look forward to seeing you guys in the next webinar. Our next one is going to be in November. I believe it's November 14th, if I'm not mistaken. It's going to be regarding the hybrid bases. So we look forward to seeing you guys next time, and we're always here for you. Till next time, you guys have a great weekend, and looking forward to hearing from everybody.